Hello everyone, I am Bharat Singla and welcome to Learn Competitive Programming with CodeChef. If you desperately want to master competitive programming and get your hands dirty in data structures and algorithms, then this is a one-stop destination for you. Every week, we upload problem explanation from CodeChef's contests, conceptual videos on various programming paradigms, and also conduct live interactive sessions. But before we start off, here's a reminder for you to hit the subscribe button if you haven't yet already. Great. Now that you have subscribed, let's get started.
Here's the problem statement, guys. So we'll be given an ant colony in the form of few lines where all the lines pass through a common point. So like this is the common point here, the point O or the origin point, right? So there will be n lines. All of them will pass through this point O, and like here there are two lines, and every line will consist of a few ants, right? So like here, this line consists of two ants and this line consists of one ant. So initially, all these ants are coming towards this point, right? So I'll be denoting the ants with these markers, right? So this denotes the direction in which they are pointing. So initially, all of them will come towards the origin, and like even if they reach here, they still move in this direction itself. So now, if two ants or two or more ants collide at any point, right? So if they are at the same point at the same time, so they will, when they bump into each other, they will just turn around and start to move in the opposite direction, right? And finally, after let's say infinite time, we need to calculate how many collisions took place. So basically, like here, it's clearly evident that, okay, let's say this is at a distance of 1, this is at a distance of 2, and this is also at a distance of 2, right? So what will happen is that first, these two ants are going to collide, right? And where it will be somewhere around here, right? So these two ants will collide here, like this will come here, and this ant will come here. So both these ants will collide, and then they will turn around and start to move in the opposite direction. So this ant now starts to move in this direction, and this ant now moves in this direction, right? These two directions. So now after this, notice that this will just keep on to move here, right? So this was one collision. And this ant, when it's coming here, notice that till when they collided, this ant also must have come somewhere here, right? So these two ants will now collide at this point, right? So this is another collision that will happen. So after that, this ant is again going to turn around, right? And now it will start to move in this upward direction, and this ant will now move in this direction. Fine. So after this, we can clearly see that this ant must be somewhere here, right? This ant is here, and this ant is pointing in the upward direction. So they will basically never collide because it was also given that they are traveling with the same speed throughout the question, right? So now we have how many collisions did we calculate? Well, the collision number was equal to 2, right? One collision was between these two ants. These were the initial ants, right? So one was between these two ants somewhere here, right? And then this ant, when it turned around, that ant as well as this ant, they hit at the origin, right? So there were two collisions basically. So we'll be given, so just to recap, we'll be given an ant colony consisting of n lines, right? And now basically they are just all traveling towards this point that will be the point of intersection of all the lines, and we need to basically check the collisions that will happen, and it's given that in one collision if two or more ants meet, so they just turn around and start to move in the opposite direction. This was the problem statement, and chef has given us this ant colony. And I, because I personally know chef, he is not lying. He has discovered all the secrets of he has discovered all the secrets of these ant colonies, and ever since he was young, he used to observe these ants. And finally, now instead of celebrating his discovery, he has converted it into a problem. Yeah, so that is the nature of chef, right? We all know that whenever he comes up with something interesting, he converts it into a coding problem, right? And now because he's not that programmer, so as usual, again we all know it's our job to help him. Yeah, so this was the problem statement, and so because it's our duty to help chef solve this problem, let us quickly move on to how we can approach the question and solve it. So the key observation in the question, like the crux of the problem, was a very beautiful observation that if two ants are bumping into each other as given in the question, and they are from the same line. Basically, they are moving towards each other and they are on the same line, something like this. So if they are colliding, as it was given in the question, they bump into each other and then they turn around and start to move. So can I, in other words, say that it is simply the two ants crossing away from each other, right? So like if these are the two ants, they are coming in this direction, they hit and they turn around and they start to move, right? So this is the same as they are coming and then they are just crossing each other, right? So like if I draw these ants, so first they are here and the second one is here, right? So after this, they'll come here and they, let's say, collide. So if they turn around, if I take the first case that was given in the question, that they turn around, so it will look something like this. They will turn around and then they will start to move, right? So, but now let's take up the other case, the way we have rephrased it. So they are coming towards each other, they collide here, right? And then they just pass away from each other, right? So this comes here and this comes here, and then they move, right? So aren't these two things the same? Yeah, so it is equivalent saying that they're bumping and they're turning around. It is equivalent to saying that they just pass away, right? And although that since if let's say this was ant one, this was ant two, so as given in the question, this will be ant one and this will be ant two and one and two, right? But the way we have rephrased it is that this is 1, this is 2, but since we are considering that they are simply passing, so this becomes 2 and this becomes 1, right? So although this is different, but since the ants are identical, we do not need to take care about that which ant is going there. We basically just want to know if there's an ant there or not, right? So they are all identical. So it is basically similar to saying that they are just crossing away and as if nothing happened. So basically two ants are coming and they just pass away without changing their direction and all. So we have basically like we have brought down the question to a very simple observation, right? A very clean observation that now we can just ignore all the complexities of turning around and collisions and all. We can simply, if we are talking about a straight line, so if two ants are colliding and we need to check the number of collisions, so we can simply check how many times they meet, right? And they are just going to, so basically, when this is ant 1 and this is ant 2, so ideally ant 1 is coming back, but according to us, ant 1 is going straight, right? So the numbers here don't matter because the ants are identical, right? So these are the two ants that are coming towards each other. So let's say there are a few more ants. Now, let's say there's only one line in the ant colony, that is n equal to 1. So this was the case for subtask 1 as well, right? So there's only one line in the colony and there are three ants, let's say with a negative distance, right? So they are basically on one side of the origin and the others are, and the remaining ants are on the other side of the origin, right? So they are coming towards each other. So the number of collisions are simply the number of times these ants meet, as we have rephrased it, right? So the number of collisions is nothing but that each ant, this ant, is going to meet all the ants on the right. Same goes for these two ants as well. So the answer is simply the number of ants on one side of the origin multiplied by the number of ants on the other side of the origin. Right, so this was the answer for subtask 1 as well, and hope this makes the rephrasing of the question and modifying the problem statement from turning around to simply passing away if they are coming from the opposite direction, right, on the straight line. So this hopefully makes it a little more clear as well. So this was one crucial observation, the crux of the problem, right? And we have literally decomposed the problem a lot and solved around 80% of the problem here itself. So now this was the first case, and now let us take the case that there are, let's say, a few more lines. So for simplicity purpose, let's take up two lines. So now notice that like even if I take the case that they are bumping and turning around or they are simply passing away, right? An ant is always going to stay in its line itself. So any of those for purpose, right? It is always going to stay in the same line. So can I simply say that if this ant is colliding with an ant on some other line, let's say this ant. So the condition for this to meet is that they are always going to meet at the intersection because an ant is never going to leave its line. So there's only one point where they can collide, and that is the origin. And the condition for that is that they should be at equal distance, right? So two ants, they are going to collide at the origin only when they are equidistant from the origin initially, because the speeds of all the ants are same. And here notice that we cannot apply the same observation that used above, because here we cannot take that they are just passing away, because then it would mean that after hitting here, the first ant comes down here and the second comes like here. But this is not the case. It is turning around, and this basically the above observation now does not make any sense, right? Because they are not at 180-degree, they are at 90-degree or some other angle, right? So we have to take care that they are turning around. Fine. So this is the second case. That is when two ants from different lines are colliding, they can only collide when they are equidistant from the origin, and they'll only collide at the origin. So this was the second observation. Fine. So now basically, like, I would still rate the problem as easy medium or medium level. Why? Because even though the solution is quite simple, coming up to that may be quite difficult, especially when you're giving the contest yourself. Basically, you do not have any aid. So, like, coming up to this kind of a solution becomes really difficult, although understanding this video tutorial might look very simple. So the difficulty level is still easy medium or medium, I say. Right? So these are the two observations, and they are mainly only the two observations required. So what we can simply do is now to check for multiple lines. So the algorithm that we are going to use is that first we are simply going to check for the collisions that are happening at this point, the origin, right? And there's a very simple way to do that. Basically, we need to check that for any point, any distance, basically, like if this is a distance of d, so there should be another ant with the same distance, right? So for that, when we are given the input, and note, and maybe I forgot to tell this in the problem statement, that we'll be given the input in such a way that there will be n as the input, the number of lines, then n lines follow, where each line denotes the not the coordinates of the ants, but the distance of the ants from the origin. And if it's negative, like -5 is given, so basically that ant is on one side of the origin on that line. And if let's say +5 is given, so it's on the other side, right? So this way, what we can do is to check that if this ant will collide at this point, what we can simply do is check that the map of, let's say, the map of the absolute of the distance d, right? This should be greater than 1. And initially, when we are just processing the input, what we can do is simply do map of absolute of x, the same expression, plus equal to 1 or plus plus, right? So what this will basically do is that, let's say I am given -5 as the input. So initially all the values in the map are 0. So what it will do is it will increment map of 5 by 1, because absolute of x, right? Sorry, absolute of d or anything like that. So map of 5 will be incremented. So now this becomes 1. Then let's say at some other time of the input, I get 5. So again, when we'll increment MP of 5, so now notice that it will now become 2. We'll increment it again. So whenever I need to check that if an ant will collide at the origin, what I can simply do is I can check that if map of absolute of d is greater than 1, basically there are more than one ants that are equidistant to the origin. So in that case, it will collide, right? So this was something that is more specific to implementation as well. Yeah, so let me just erase this mess that I have made here. So, so yeah, coming back to the algorithm, and what basically we are going to do is that, let's say I take up this ant, right? So we are going to separately count the number of collisions that every ant will have, plus the number of collisions that will happen on the origin. Because the problem with origin is that there could be more than two ants that are meeting. Like if this is one ant, this is one ant, and there could be another ant like this, which has the same distance. So there are three ants colliding. So basically, it's better that we calculate the collisions happening at the origin like different than what's happening otherwise, right? Because then we would have counted three collisions, but there's only one collisions that actually happening, right? So it's better to calculate collisions happening at the origin plus the collisions happening externally, right? So what we are going to do is that, let's say I take up this ant, right? So for every ant, let's say this ant, what I'm going to check is that if this is colliding at the origin, then it will definitely come back, right? And when it's going to come back, it will meet all the ants that are on the left. So if let's say there's another ant like this, so if this ant will turn back, so it will now move in this direction, so then it will definitely pass through all these ants, right? Now we can use that observation that we made above. We can just basically pass through all them. So if an ant is colliding, then we can simply increment the answer by the number of ants on the left, right? And let's say if it's not colliding, then what we can do is it will simply pass on, right? It will just go on ahead, and then it's going to collide with every ant that is on the left, that is on the right of the ant, right? Basically on the right of the origin. So two ants in this case, right? And instead of taking any random ant, and the benefit of taking a more specific ant, that is the one which is the closest to the origin, right? So the added benefit of that is that, let's say I took this ant, right? So it is not guaranteed. So we'll basically have to make up a lot of cases for this. So first is that if it is colliding, then it's going to definitely meet the ants on the left, but it can also meet the ants on the right, which are the left of origin, which will also come back, right? Because this will go, and if let's say this is also reflecting, so when it is here, and it's counting as a collision. By taking any random ant, we could have taken up a lot of cases, right? If it is colliding, if there's any ant on the right that is colliding and coming back, and are the ants on the right with a distance less than what the distance of this ant is, and we could have taken up a lot of cases, but this really confuses the implementation, right? And makes it very hard to code, and there's a high chance we could have got a wrong answer. So instead, and this is basically not wise to be done by complexity also, right? You can do it using binary search and all, lower bounds and upper bounds, but yeah, this is something not ideal. So what instead we can do is, let me just redraw this. So instead what we can do is that we are at every point going to take the ant that is closest to the origin, right? So if these were the three ants, right? And this was another ant, and there are two ants here. So I am initially going to take the ant which is closest to the origin, right? So first I'm going to take this ant, only then I'll take care about these ants on the left. So this is the closest to the origin. So what this basically implies is that it will reach the origin first. And what this basically implies is that I can again simply, if it is reflecting, basically it will collide at origin. So it will move back and it will meet all the ants on the left, and the number of ants on the left are simply the total number of ants minus 1, excluding this ant, right? Because this has to be the rightmost ant. And otherwise, if it's not colliding, then since it is reaching the origin first because it's the closest, then definitely there must be, let's say, some other ant that would be here right now. So this would have not reached the origin before that because it's the closest. So if it's not colliding at the origin, so definitely it's going to meet all the ants on the right. So for this ant, if there are two cases for the closest ant, if it is colliding, then it's meeting all the ants on the left. And if it's not colliding, then it's meeting all the ants on the right. And after that, we can simply remove this from our stack or DQ or list or array or vector or anything you want. Yeah, so so we can basically remove the ant because we have counted the number of collisions. And now we are going to take the next closest ant. Let's say this is the closest ant. So it is not colliding basically at the origin, so it will move straight. So since there's no ant ahead of it, so there's no collision, we can remove this from our list as well. Then we are going to take the next closest ant, which is, let's say, this ant. So it is colliding, so it will definitely come back and meet all the ants. In this case there's only one ant here, so answer plus equal to 1. We can remove this as well. Then this is our closest. Then this is not colliding at the origin, so it will simply move ahead and again meet all the ants on this side, right? So again this was only one, so answer plus equal to 1. We can remove this ant as well. Then this ant is going to collide, so it will come back, right? And there's no ant now on the left of this ant, so answer plus equal to 0. We can remove this, and same goes for this as well. So we have basically calculated the number of collisions that took place. And this is the algorithm. And remember, we need to count the number of collisions that happened here as well. And that is nothing but the number of unique distances, basically unique distances with the number of ants with that distance greater than 1, right? So in our map, if let's say for any key, the value associated with it is greater than 1, basically for that distance, like the key is a distance, right? And if there are more than one ants there, so there's a collision happening, so answer is equal to 1 in that case as well, right? So this is how the algorithm goes. So if you were not able to solve the question, then hopefully after you watch this video tutorial, you will be able to understand the solution. But one thing I wanted to convey is that like this is just one problem. Maybe after this you will be able to solve this and even very similar problem to these. But what about problems revolving around other CP topics, right? What about problems from the future CodeChef contest or any upcoming problem that requires some different competitive programming topic? So to really get better at problem solving, you need to become conceptually sound, right? And to learn new concepts instead of just searching all over the internet, CodeChef is a one stop and a prime location for you. And if you did not know that on Unacademy, CodeChef also conducts live interactive sessions and where we try to post literally every topic related to competitive programming. Like we have courses, we have micro courses, we have live interactive classes for all skill levels from beginner to the very advanced, right? And these classes are conducted by the top coding experts from around the world who are IOI medalists and ICPC world finalists. So they are 6-star and 7-star coders and there are mentors for your help as well. So to really get better, and I highly recommend that you take the CodeChef's competitive programming course so that not just these problems, but even coding interviews become a cakewalk for you. And also make sure guys, while registering, don't forget to use the code Bharat27 to get an instant and additional 10% discount as well. So hurry up guys, quickly subscribe to Unacademy Plus so that you really get better at logic building and problem solving. So here's the code guys, which will be in C++. So first taking the input n, right, and a vector of vector ends of lines. And remember we also had to make this map MP, right? So where MP of x denotes the number of ants with the absolute distance of x. So now looping from 0 to n. And another thing to note is that this vi and loop, they are not like the native functions of C++. These are something I have defined in my template. Yeah, so looping from 0 to n, then just taking the input and pushing it to the vector lines. And remember to just increment map of absolute of and plus plus, right? Then answer equal to 0. Since the collisions could be a lot, there could be a lot of collisions, we need to take it long, right? So then reversing if like and dot ss, basically and dot second, which denotes the number of ants with that distance. If there are more than one ants for any particular distance, then simply increment answer by one. Basically, there's a collision at the origin, right? Between ants of those distance. Then traversing on each line and maintaining two vectors, negative and positive, where both of them are going to store the ants which are on one side of the origin and positive will store on the other side of the origin. Then just pushing them. And remember, we are going to leverage the fact that in the constraints it was given that for each line, the ants will be given in sorted order. What this basically means is that we don't need to sort it again, but because we want the closest ant, to the origin on the back of the vector. So since pushing back appends it to the back and that makes the farthest ant come to the back, we are going to reverse this positive vector. Fine. So now while to loop, then finding the closest ant to the origin, and we'll find the number of collisions for that and remove it from the list. So now if both the vectors are empty, there's no ant left, so break out. Otherwise, if negative is empty, then closest has to be the positive dot back. Else if positive is empty, closest is negative dot back. Otherwise, there are two cases that the closest belongs to the rightmost negative ant or the leftmost positive ant. Right? So these are a check and ternary condition to assign the closest ant. Now, if closest was the one from the negative vector, and it was going to collide at the origin, then it's definitely going to reverse around and meet all the ants on the negative vector except for itself, right? Otherwise, it's going to pass through and meet all the ants on the positive vector. Same goes for the ant if the closest ant was on the positive side. Fine. And then also we need to remove it from the vectors. Then finally, we can print out our answer and just call this solve function within the main function. So this was the code, and now let us quickly submit it. But remember guys, don't just watch me code out the solution. After the video ends, try to code it out yourself to gain the confidence that yes, I was fully able to understand the question. And this also enhances your implementation skills, right? And don't forget to smash that like button if you get an AC. So yes, this was a correct answer. And this also winds up the video.